Good morning, dear students. So far in this chapter till now, we have discussed the behavior of electromagnetic waves in a medium of dielectric with finite mu and epsilon but sigma equal to 0. Now in my current video, I am going to discuss the behavior of electromagnetic wave in a medium with finite values of mu, epsilon and sigma. That means it is a conductor. For the conductor, sigma is always having a finite value which is not equal to 0. Now any medium with finite values of permeability mu, permittivity epsilon and conductivity sigma is known as the conductor. It can be distinguished from a dielectric medium in a way that for dielectrics there is only the displacement current that flows, but for a conducting medium, except the displacement current, conduction current also flows. That means sigma is not equal to 0, for which gives J vector which is equal to sigma into E which is not equal to 0. My dear students, I must tell you over here in my last video that J vector is equal to sigma into E vector. It is a well known microscopic form of Ohm's law and all the conductors must obey this Ohm's law in microscopic form. Now, since the conducting medium is electrically neutral, so for the neutrality of the electric medium, we can consider that the absence of free source charges, that is the charge density rho must be equal to 0 because when there are no free charges, the free charge density must be equal to 0, that is rho is equal to 0 everywhere. So now this consideration can be taken into account by considering the four Maxwell's equations I have discussed earlier in my start of the chapter. Now see over here students, I have taken the four equations of Maxwell's again. The first equation is del cross E which is equal to minus curly B upon curly T. Now you know very well that B is equal to mu H. So using over here you will get minus mu curly H upon curly T as equation number 1. Similarly, del cross H is equal to J vector plus curly D upon curly T. D here is the displacement vector and curly D upon curly T is known as the displacement current. Now using the values of J as sigma into E and D as epsilon into E, I will get equation number 2. Now similarly the third equation is del dot D equal to rho. Here you can use the value of D equal to epsilon into E. So using and simplifying the equation, I'll get del dot E is equal to rho over epsilon. But for a conducting medium, since there is no free charge density, means rho is equal to 0, so you can directly take the right hand side as 0. I'll get equation number 3. Fourth equation of the Maxwell is direct, that is isolated magnetic poles do not exist. So for which I'll get del dot H equal to 0 as equation number 4. Now we have to discuss the behavior of first for electric field in the conductors. Now for this purpose what I do, I take curl of equation number 1 on both sides. Curl means you have to multiply the equation number 1 with del vector, means you have to take the cross product of del vector with the first equation on the both sides. Alright, so I'll get this type of equation, del cross E is equal to del cross minus mu curly H upon curly T. Taking the mu, negative of mu outside of the differentiation sign and taking del vector inside of the differentiation sign, I'll get minus mu curly upon curly T of del cross H. I can't replace this cross. I will have to keep this cross as it is. So del cross H, equation number 5. Now dear students, you know the vector triple product can be expanded into this form. A cross B cross C. It is A dot C means del dot E into B means del vector minus A dot B means del dot del into C vector means E vector. This is taken as equation number 6. But already I know that del dot E is equal to 0 from equation number 3. So I'm going to use equation 3 here in equation number 6. I'll get this term as 0. If del dot E is equal to 0, del dot del becomes del square. So I'll get del cross E is equal to minus del square of E vector. So now using equation 7 on the left hand side of equation number 5 and using equation 2 on the right hand side of equation number 5, I'll get the similar equation as like this. So now you can expand this equation and negative sign on both sides get cancelled. Then move the two terms on the left hand side, you will get equation number A. Now this is the equation for discussion of or the propagation of electromagnetic waves for the electric wave. This means this equation shows how the electric field behaves through a conductor when an electromagnetic wave passes through a medium. Dear students, if you remember our previous equation, this term was 0 for the dielectrics because sigma is equal to 0 for dielectrics, and for conductors sigma is finite, so you are getting the third term as well. Now similarly for H vector means to discuss the behavior of magnetic field in the conductors, I'll take del vector cross means taking curl on the both sides of equation number 2. Your equation number 2 is this one, del cross H is equal to this one. Now take del cross on both sides, I'll get this type of equation, del cross H and so on. Now expanding the left hand side using vector triple product, I'll get del dot H into del vector minus del dot del into H vector. Right hand side can be expanded as sigma outside del cross E, then plus epsilon outside curly upon curly T of del cross E. This is your equation number 8. Again using the fourth equation, del dot H is equal to 0, del dot del is equal to del square, and the first equation del cross E is equal to minus mu curly H upon curly T. I'll get this type of equation. So on expanding this equation and cancelling throughout the negative sign, moving the two terms on the left hand side, I'll get equation number B. So you can now compare the equations A and B. You can see over here both E vector and H vector, these are following the similar type of equation, which is the wave equation of electromagnetic wave for electric and magnetic fields when electromagnetic wave passes through the conductors. So equations A and B show that both E vector and H vector are coupled and follow the same wave equation when the electromagnetic wave passes through the conductors. Now since these A and B equations are clearly written for three-dimensional wave, but in my case, in my chapter, I am going to discuss about the plane polarized electromagnetic wave. So consider such a plane polarized electromagnetic wave traveling along x-axis in which electric field is directed along y-axis and magnetic field is directed along z-axis. Your equations A and B will get improved now. Now see, del square will be improved into curly square upon curly x square because my wave is propagating along x-axis. E vector in equation number A can be replaced with Ey, whereas H vector can be replaced with Hz. So equations A and B get modified into the forms of equations C and D. For electric field, my A equation becomes curly square Ey upon curly x square minus mu epsilon curly square Ey upon curly t square minus mu sigma curly Ey upon curly t is equal to 0. This becomes the electromagnetic wave equation for electric field for a plane polarized electromagnetic wave through the conductors. Similar equation you can get for the magnetic field as well. So in this equation B, just replace del square with curly square upon curly x square, H vector with Hz. So you will get this type of equation D from equation number B. This equation D is the equation for the magnetic field when electromagnetic wave passes through the conducting medium. So hence equations C and equation D are the wave equations for a plane polarized electromagnetic wave through the conductors. This is all about the topic. Now my dear students, this topic is not yet finished over here. Now we have to derive the solutions of these two wave equations further when the electromagnetic wave passes through the conductors. I think this is sufficient for today. We will derive its solutions and their values for the electromagnetic waves through the conductors in our next video. Till then, read this lecture, enjoy this lecture and try to grab it. Thank you so much.